Welcome to the deep dive. Today, we're taking a really close look at something huge that affects us all, but often stays hidden, the global supply chain.
Mhm.
And it's not just, about where your coffee comes from. It's this incredibly complex web that brings us everything, microchips, medicines, you name it, right to our door.
Absolutely.
But here's the thing. Its complexity is also its weakness. It makes it really vulnerable.
Right.
Just think about recent years, a pandemic, geopolitical tensions, weird weather events, even just one supplier having a problem.
Yeah.
It can send shockwaves everywhere, disruptions galore.
It really can cascade, can't it?
Exactly. So the big challenge isn't just spotting potential problems, it's actually understanding what happens next. The ripple effects. How does it hit operations, costs, getting stuff on shelves, and critically, what can we actually do about it beforehand?
Yeah, how do you prepare?
Right. And this matters to everyone, really. CEOs trying to build resilience, sure, but also students just trying to figure out how the global economy even works.
It's fundamental.
So that brings us to our focus today. A pretty powerful tool called Simul8. It gives you a very practical visual way to model these complex supply chains and see what happens when things go wrong.
Exactly. And for anyone listening who wants to really get a handle on this stuff, maybe find a shortcut to understanding it deeply, Simulate is fantastic.
How so?
Well, it lets you simulate these real-world supply chain dynamics. You can actually map out the risks, and then you can play around with what-if scenarios.
Okay.
Test different responses, all in a safe virtual space. And the key thing, you're not messing with your actual business operations while you figure it out.
Okay, right. Let's unpack that a bit. What is Simul8, fundamentally?
Well, at its core, it's a simulation tool. It uses a technique called discrete event simulation, or DES.
DES. Okay. What does that mean in practice? Is it like a spreadsheet?
No, not really. It's quite different. Instead of just static numbers or averages, think of DES, like building a mini digital version of your whole operation.
The digital twin, almost.
Sort of, yeah.
Yeah.
And then you watch events happen over time. A product moves here, a machine stops working there, an order gets processed. You see the flow.
You see the interactions and the dependencies.
Precisely, at a really granular level. And it's not some obscure academic thing either. It's used everywhere. Logistics, manufacturing, even healthcare, service industries, you name it.
So what's the main goal for users?
Basically, simulate your processes, see where things get stuck, the bottlenecks, and then test out potential fixes before you spend any real money or change anything in the real world.
That makes sense. So why is that better than, say, using those spreadsheets you mentioned?
Well, spreadsheets are great for certain things, static calculations, but supply chains aren't static. They're messy. They change constantly over time.
Right. Things happen unexpectedly.
Exactly. And that's what's so fascinating here. Simulate is built to handle that randomness, those delays that always pop up, the variability in demand or production times. It's baked in.
So it's not assuming a perfect world.
Not at all. It's a difference between like looking at a single photo versus watching a movie of your operation. That dynamic element, that's crucial for understanding real-world supply chains because they are unpredictable.
That dynamic real-time aspect sounds like a total game changer. So if someone's listening and wants to really get into supply chain analysis, what are the key Simulate features that make this possible?
Okay, yeah, good question. One of the big ones, and what makes it pretty easy to pick up, is the visual process modeling.
Visual. How does that work?
Think of it like a digital whiteboard. You literally drag and drop icons representing things like factories, warehouses, trucks, onto the screen and connect them to map out your entire supply chain.
So you can actually see the flow you're building.
Exactly. It's very intuitive. You build it visually end to end.
Okay, so you've built your model visually. Then what? How do you test it?
Now that's where the scenario testing and what-if analysis comes in. And honestly, this is often where you get those real aha moments.
What kind of scenarios?
Well, you could simulate something specific. Maybe a key supplier suddenly shuts down for a month, or a major port gets congested. You model that disruption.
And see what breaks.
Yes, but also test solutions. Before using tools like this, maybe a company would just panic, right? Pay fortunes for emergency air freight.
Yeah, reactively.
Right. But with simulation, you might test, say, rerouting through a smaller nearby port you hadn't considered, or maybe adjusting safety stock levels just so. And you might find a strategy that dramatically cuts the impact, something you'd never have guessed without testing it virtually.
That's powerful. So it guides you towards better solutions, not just identifying problems. And what about that unpredictability you mentioned earlier? How does it handle random events?
That's where stochastic modeling is key. Stochastic just means it involves randomness.
Okay.
Anyone who works in logistics knows things rarely go exactly to plan, right?
Right.
Lead times vary, demand spikes out of nowhere, machines break down unexpectedly.
Absolutely. Murphy's Law.
Pretty much. So this feature lets you build that real-world uncertainty right into the model. Your simulation doesn't just run one perfect path. It runs many times, incorporating that randomness.
So you get a range of possible outcomes, a more realistic picture.
Exactly.
But
Much more realistic than a simple average could ever give you. And while all this is running, you've got KPI dashboards.
key performance indicators.
Right. So you're watching key metrics in real time during the simulation.
Huh.
Things like lead times, how well you're meeting customer demand, service levels, inventory costs, how much stuff is actually getting through the system throughput.
So you can see immediately how different scenarios affect performance.
Instantly. It gives you those actionable insights.
And does this tool live in its own little world, or can it connect to the data businesses already have?
Oh, definitely not isolated. That's crucial. It has strong integration capabilities,
Meaning?
meaning it can pull data directly from things like Excel spreadsheets, company databases, or even those big ERP systems, enterprise resource planning software.
So you can feed it real historical data, or even current data.
Yep, which makes your simulations incredibly grounded in reality. You're not just making up numbers. You're using your actual operational data to drive the model.
That makes a huge difference in terms of relevance. Okay, so connecting all these features, let's talk practical applications. Where do you see this being used effectively, especially thinking about, say, students or researchers trying to understand these systems?
Oh, the applications are really broad. You can start big with modeling global supply chain networks.
The whole thing.
Yeah, simulating everything from getting raw materials through manufacturing, warehousing, distribution, right across different countries. You can see how a decision made in one part of the world impacts another.
Wow.
Then you can drill down into specific disruption scenarios, like actually model the impact of something like the COVID lockdowns. What did that really do to performance? Or simulate a shortage of a critical component, like semiconductors.
Testing resilience.
Exactly. Which leads straight into risk mitigation strategy testing. You've simulated the disruption, now you test the fixes. What works better? Having two suppliers instead of one. Keeping more safety stock. Maybe even moving production closer to home.
Comparing different approaches side by side.
Precisely. Compare them under different conditions to find the best balance between cost and, not getting caught out.
Makes sense. What else?
Well, it's great for inventory optimization. Forget static formulas. Simul8 helps find the dynamic sweet spot for reorder points and safety stock, considering all that variability we talked about.
So less guesswork, fewer stockouts, or piles of unsold inventory.
Hopefully, yes. And very relevant today, you can do green supply chain simulation.
Sustainability.
Modeling things like carbon emissions, waste generation, energy use within the supply chain. This helps design networks that are not just efficient and resilient, but also more environmentally sustainable. That's a huge focus now.
It really does seem to cover the major challenges. That breadth is impressive. And it brings us back to why this might be particularly good for academic work for students listening. You mentioned it was intuitive, but does it require programming skills?
That's a key point. Generally, no coding is required.
Really?
Yeah, the visual drag-and-drop interface makes it accessible even if you're not a programmer. That lowers the barrier to entry significantly.
So students can focus on the supply chain concepts, not getting bogged down in code.
Exactly. But it's not simplistic. It still offers realistic process behavior. It captures the details, queues forming, delays happening, resources being tied up, things that simpler models often miss.
And does it connect to standard industry practices?
It does. For students learning about process improvement, it supports Lean and Six Sigma methodologies, those frameworks for efficiency and quality. The tool aligns well with those principles.
That's useful. What about the scale? Can you start small?
Absolutely. The models are scalable. You can begin by modeling just one part of a process, a single distribution center maybe, and then gradually build it out into a full global network simulation.
Flexible.
Very. And maybe the most practical point for education. They offer free educational licenses.
Oh, that's huge for students and universities. Removes the cost barrier.
It really does. Makes it a fantastic learning resource.
It sounds like it genuinely equips students to tackle complex, real-world problems using a proper industry tool. It lets you really get into the weeds.
Absolutely. And you see that reflected in its use for things like final year capstone projects or research. People use it for detailed supply chain risk management simulation or figuring out optimal just-in-time inventory strategies.
Well,
Things like balancing workloads in huge distribution centers, analyzing the impact of unreliable supplier lead times, even designing complex transportation networks. It lets you rigorously test ideas that would be impossible or way too risky to try out in the real world first.
right. So wrapping up our deep dive here on Simulate, the core idea seems to be that it provides this powerful, visual, and importantly accessible way to really understand supply chain vulnerabilities.
Hmm.
And then, crucially, to figure out how to mitigate them. It's like a safe sandbox for making really critical decisions.
That's a great way to put it. A safe space to test, learn, and optimize before you commit resources in the real world. Saves time, saves money, reduces risk.
Yeah, avoids a lot of potential headaches down the line.
So what does this all mean for you listening?
Well, getting to grips with tools like Simulate, it really gives you an edge.
How so?
It helps you understand the resilience, the optimization, the inner workings of these massive global systems that, let's face it, affect everything in our daily lives. You move beyond just theory.
Into practical application.
Exactly, into
Yeah.
practical, data-driven problem solving. And that's a skill set that's only becoming more valuable.
Definitely. And maybe a final thought to leave you with. Consider this.
Yeah.
How might simulations like the ones we've discussed today go beyond just optimizing business? Interesting question.
Could they fundamentally change how we as a society prepare for and react to really big, unforeseen global shocks? Think climate change impacts, future pandemics.
Yeah, using simulation to ensure critical supplies keep flowing.
Exactly. Could simulation be a key tool in building that larger scale resilience, making sure essential goods can always get to where they're needed most, no matter what disruption comes next? Something to think about.